today, boys and girls, we are going to be doing our Module 3, Lesson 24. Our objective today is determine if a whole number is a multiple of another number. So yesterday, can somebody tell me, what did we do to get ready for this lesson, Riley?
We did the associative property.
All right, we use the associative property. We use that to test for factors. Now, we have been talking about factors and multiples all year long, so hopefully this will kind of help us relate this to our division that we've been doing, okay? So that is what we're going to be working on today. Now, in order to get our brains thinking, we're going 4s to 40s, getting a little bit harder, okay?
4, 8, 12, 16, 20, 24, 28, 32, 36, 30.
Oh, yeah, after 36 is 40. All right, now, hopefully this should be the easiest one, 5s to 50.
5, 10, 15, 20, 25, 30, 35, 40, 45, 50.
Very good. All right, so now what you're going to do on your whiteboard, I want you to tell me, you can just write P for prime and C for composite. Is 5 a prime or composite number? All right, then I would like you to list the factor pair of 5. So we're going to review this. All right, very good, Lily. Good, Caitlin. Good, Graham. All right, now I want you to, is it prime or composite there, Shante? Write a P or A. All right, very good. I see 100%. It is a prime number with a factor pair of what, boys and girls?
1 and 5.
Perfect. Last one, and then we're going to move on from our fluency. 12. Is 12 prime or composite? Then I would like you to list the factor pairs. So this is reviewing what we learned yesterday. All right, and factors and multiples, sometimes that vocabulary, people get a little confused. But remember, factors are the actual numbers that you are multiplying together, and the multiple is the product, the answer to that. All right, very good, John. Hollis, good, good, good. I should see 6 factors right there.
Yes.
All right, very good. And I see the rainbow. Excellent job, boys and girls. All right, so now, we're not going to do all of these. We are going to test out for factors, because now really this is going to be what's important for our long division, is being able to test a factor. So I want you to look at this list of numbers on the board, 30, 45, 48, 56. On your personal whiteboard, write the number that has 10 as a factor. So we're testing all these out, but not only are you writing it, you're going to have to be able to explain it to me. So Lily, I see that you have written 30 on your board. Everyone has written 30, which is great. But how did you know so quickly that 30 was the factor of 10?
Because it ended in a 0, and
Oh.
that helped me out.
Right, so yesterday we talked about some divisibility rules, and anything that ends in a 0 could be a factor of 10. Very good.
Is a factor.
Is a factor of 10. Right. 45 would not be able to work because it does not end in.
A
Now,
multiple.
45 could be divisible by 5, but not 10. All right, and the same thing with 48 and 56. All right, let's test this out. Same numbers now, but now write the division equations that prove that 5 and 2 are factors of 30. Good. So I'm going to hold Ava Kate's board up. Let's see if we agree with her. She wrote 30 divided by 5 is equal to 6. Is that a true statement?
Yes.
If it's true and it divides in there equally, that means it is a factor. Does 30 divided by 2 equal 15? Yes. These are the division equations that I was looking for. I want you to take a look at that same list. And now, which numbers can have 6 as a factor? Think about all the numbers that can have 6 as a factor and write the equation that will help you prove it.
Here you go.
Have some people, what I would like you to do is look around at other people's boards and y'all discuss. Some people have 2 written down, some people have 3 numbers, some people have 1. Y'all discuss and see if you agree with one another before I go over it. So y'all talk about it and see. notice that pattern where it's going like from 4, and then it may go to 8, then it goes to 2, then it'll go to a 6, and then it ends in a, goes back to a 0, and then it flips, it goes around again. So now that we know that, we're going to do this again. All right, are we ready? All right, on your mark, get set, go. 168. Okay, 116, 124. All right, time's up, boys and girls, so let's write down what we went to this time. So hopefully, now that you kind of saw that pattern, now that we saw that pattern, it may have made it a little bit easier. Class. All right, listen, I heard some great discussion, and I know, because I was working with Ava Kate since we had an odd number today, that it made counting those larger numbers a little bit easier. Once I figured out what a pattern was, I was looking for those. I know that I would get it wrong if I came something that ended with a 3, because that's not part of the pattern. Now, think closely. Yesterday we worked with factors. How is a multiple different from a factor, Kingsley?
A multiple is different from a factor because a factor is like a number that can make up that number.
Okay.
You know what I mean? And a multiple is that number times something else to make the multiple.
All right, right. Remember yesterday when we did our near pot, or when we did our near pot on Monday, multiples, I liked how that you said that example. It's like the product. It's like the answer to the multiplication problem. And the factor were the 2 numbers. So Kingsley, that was a good explanation. It's the 2, she said the 2 numbers that make up the number, right? And then the multiple was kind of like the whole. It's kind of like the answer to it. All right, and I do like that. That's kind of something. Remember the little guy in our video said multiples have that word. What do you see in it? Multiply. So it's the numbers you have to multiply to make that product.
Even in that mini cartoon,
Right.
I saw that one.
So now let's look at this. Why is 24 a multiple of 4? Can anybody prove to me why 24 is going to be a multiple of 20? Why is 24 a multiple of 4? All right, Lily has a proof. All right, write something on your board to prove to me. All right, Lily, what? Lily has some proof for me. All right. All right, Shantae has some proof for me. Kennedy has some proof, and I love looking at the boards. There's 3 different kinds of 24 multiple of 5.
No.
All right, why do we know that?
Because it has to end with 5. It has a remainder.
All right, now listen, it would have a remainder, good. Riley said it has to end in a 5 or a 0, and if we were to actually list our multiples of 5,
There is no top. 24.
when we get to between 20 and 25, that's going to be it. And you can see the pattern, 0, 5, 0, 5. Use division to find that. All right, I'm seeing some skip counting on here to list the multiples. Good.
I want to make this
I can look and see. Yes, 24 is a multiple of 8. Good.
I did every
Now,
single thing.
what happens when we start getting to these bigger numbers? This is why this is important, because when you go to 5th grade and you start dividing these larger numbers, you have to kind of know those multiples, and you need to test for factors and see if it goes into these larger numbers. Now, we know 96 is a multiple of 4 from our application problem, right? Because we had that. Since 4 times 24 is 96, what did we do to figure that out? What did we do, Graham? We did division. We said 96 divided by 4. Yes, we did. It's 24. That's what a lot of you did. You used that long division. Absolutely. Now, how could we find out if 96 is a multiple of 3? What could we do? How could we find out if 96 is a multiple of 3? We could use long division. So I want you to test that out for me.
If we use multiplication, that would take too long.
Right, so now, I guess my point is, yes, skip counting, listing our multiples is definitely a strategy, but it gets to be a lot when you're doing 3, 6, 9, 12, 15, and you're trying to go all that too. Now, now you know how I feel about the associative property. Can you use that associative associative property?
Yes.
Yes. How could I use the associative property to test that? Yesterday we used that associative property with 2 and 3. We were breaking 6 up apart into 2 and 3. Let's break one of these bigger numbers up. So can I rename 12 as a smaller multiplication fact?
Yes, you can.
Well, since I'm trying to test it to see if it's a multiple of 3, I want to use 3 in here. So what can I rename 12 as, Kennedy?
3 times 4.
So I want to put 3 times 4, okay?
Is this right?
Well, we're about to check that, Shantae, and see. I'm going to bring down my 8, okay? Where could I place those parentheses? Jaslyn, where could I place those parentheses? Where could I place it?
Some in between 3 and 4. Like behind 3 and behind.
Alright.
24.
What is 24 times 4? Let's make sure that it equals 96.
96.
So is 3 a multiple of 96?
About this way.
Or I'm sorry, I said that backwards. Is 96 a multiple of 3?
Yes.
Now listen, it would not be a multiple if it did not go in there evenly. If I can break it apart and test it out, I can actually see that, okay? Now, could I have done it a different way?
Yes.
Yeah, I definitely could. I could have flip-flopped that 4 over here and said 8 times 4 is 32. And then 32 times 3. And if we would have tested that out too,
And we just did that.
it still would.
Yes.
Yeah, I mean, you could. That could be another strategy to make it a little bit easier. Yeah, you could do that. Is 96 a multiple of both 3 and 32?
Yes.
Did we just prove that?
Yes.
We just proved it by
You
counting.
can do 3 times 32 or 32 times 3.
You can definitely do that.
Or
Very good.
96.
Now, let's list the first 5 multiples of 3. All right, so something easy. What's the first 5 multiples?
3, 6, 9, 12, 15.
Is any multiple of 6 also a multiple of 2 and 3?
Yes.
Yes.
How did we know that from yesterday?
That's what I was just about to say.
Yesterday, we did all that testing of factors, and we would take 6 using that associative property, and we were multiplying. 2 times 3 equals 6. That's exactly right. Now, watch them test this out using a very simple, Shantae, multiplication problem. They took 6. What did they break it apart as? 2 times 3. They moved those parentheses around. They got 10 times 2.
20 times 3.
That's 20 times 3 equals 60.
Yes.
Now, I could even have flipped it around and I could have said, okay, let's do 10 times 3 times 2. Does 30 times 2 equal 60? Yes. So, here's the divisibility rule for the 6's. If a number is divisible by 6, guess what it's also divisible by? 2 and 3. 2 and 3, because of the associative property, we can rename that. Right. Alright, so now we already did that. So yes, 60 is a multiple of 3, because if we count by 3s, we are eventually going to get to 60. How many 3s do we need to count by? 20. 3 times 20. That is a lot. So now, this is save that for whenever we go into our groups for next week to work on this. But I do want to ask you a couple of questions. My main focus that I want you to take away, what's the difference between factors and multiples? That's what we really need to know. What is the main difference? I want you to talk with your group, and I want you to tell them what is the main difference.
Factors are what equals the number and multiples are what
Factors are what you use to multiply a number, and multiples are what.
Multiples are just a whole.
Yeah.
Yeah,
That's why I just said.
Demonstration.
Multiples are like 6 and 4 and are both of the factors. And then factors are the
Factors are
You know the factors.
These are the factors.
So what about the multiples?
This is the multiple.
Yeah, this is the factor and this is the multiple.
Alright, now, class. Alright, I heard some great discussions. The factors are the two numbers you are multiplying together. The multiples are your whole. Those are what we we see the word multiple, we think multiply. My last question to end. There's only one number that can be a multiple of every number. Does anybody remember what it is?
Zero.
Very good.